A warm welcome to Professor Sidney Brenner, Nobel laureate. Without whom biology in the 20th and 21st century would not be the same. So I don't want to make accolades here, but you all know the triplets, the C. elegans, and many, many, many other things. Instead of using Sidney's time, I give the word to Sidney and ask him to give a short talk, as short or as long as you wish, Sidney. The word is yours. There is a microphone on you, and we put it on. Yes.
Thank you. Well, I had come here to listen to the last talk, but I'm afraid I'll have to wait for the video to see it. I just want to make a few remarks about nervous systems in general, and why I think, in particular, the human nervous system, the brain, is going to be not only the most important area of biological research for the foreseeable future, but it underpins most of what will come to be practiced by the 8 billion specimens of that species that occupy the world. It's one of the interesting things about evolution is that for any given step in it, there is a limit to what organisms can do. And the limit may be set in very simple organisms like bacteria by just having enough material there to obtain energy and to obtain the chemical materials for future growth. But as we can see throughout the evolution of species, as we go from very simple microorganisms to more complex cells, to groups of cells, to metazoa, right up to the animals themselves. But at each stage of complexity, as it increases during evolution, that always seems to reach a limit. And then organisms resort to other means in order to achieve their reproductive fitness and survive. And I think that if you look at it from that point of view, then you can see that you can begin to understand why animals travel in herds. You can begin to understand why animals now, that is, interaction between individuals becomes very important to ensure the survival, and so we have the elements of social organization, especially with the social insects. These are very simple devices. And of course, when you come to the top level, that is to ask, what could the chimpanzees do when they'd finally achieved this height of primate evolution? Then the only one step remained. I think the biological resources had been exhausted. The genomes are much the same of all mammals. Nothing special about primates. But the most interesting thing is they created another step. And that step was the ape of which you are members, called Homo Sapiens. What this animal did was just have a bigger brain. At least that's what it looks like. It's not a brain of a different fundamental quality, but by expanding the number of neurons, somehow, and that still is for us to discover, somehow this organism managed to then enhance the complexity of interaction inside this organ, so it began to think. Now, if you think about this, then of course animals may look clever. They actually don't think. And as proof of that, there are no chimpanzees, remember this audience. They wouldn't qualify even to go to a primary school. So what is this about the human brain that has enabled it to take this next leap? So we're only 6 million years away from chimpanzees. And as you can see, not only is this brain being used to uncover new ways of getting food and all the elementary things, but it also created science, technology, and in fact created social interactions, which of course, many of which have not yet been solved. So that is why I think the study of the human brain in particular becomes an essential, fundamental basis to the whole of future science. Because we can understand not only human activities, but we can begin to understand history, we can begin to understand the structure of social interactions, we can begin to ask in what way are these optimal or not, and we can begin to understand this great aspect of the human brain, which, for want of a better word, it is the imagination. It is being able to look into the future. All animals, many animals, can look into the past. That is, they have memory. But none can look into the future and devise methods of contending with situations of which they have no experience at all. So I think that is going to be not a quality that we will find, except that it is embedded in the structure itself. I think it is the property of the interaction of many cells that allows us to do all the things that we are capable of doing and will be capable of doing in the future. I think subjects like psychology, sociology, even economics are going to have to benefit from this understanding of the capacities and the inclination of this bunch of meat inside your head, of what it is capable of. So it is very good that there are people who are interested in brains, and there are people like yourselves who have been carrying it forward into completely new regions, beyond what Cahal did, and the early people who studied brain anatomy did. A program which is still not anywhere near complete, and which I think we will have to learn more about the structure and its function to understand what it is capable of producing. So I think that without this understanding of what we represent, sitting now right at the advanced point of historical change. We are sitting right in the front line here. I think that is essential for people to grasp, because only in that way will we release the capacities that are present in the 8 billion individuals that populate the world. So I have no slides because I don't know what to show you on a slide. And anyway, I never use them, and I'll tell you why. Because they switch off the lights and everybody falls asleep immediately. But I can now see who's sleeping in the audience, and I can wake you up. Thank you very much.
Thank you so much, Sydney.
Thank you.
Thank you.